Let's now briefly talk about SysML v2. I'm going to provide a few slides that discuss the objectives, the key elements, and the capabilities of SysML v2. The objectives for SysML v2 are to increase the adoption and the effectiveness of MBSE with SysML relative to SysML v1. And in particular, we want to enhance various aspects of the modeling effort. We want to have a model that is more precise, reduced ambiguity. And we want to have a model that is more expressive, that expresses more of the systems engineering concepts. We want to ensure consistency and integration amongst those language concepts. We want to ensure interoperability with other engineering models and tools. We want to enhance usability by both those who develop the models, the model developers, as well as those who consume the model information. We want to provide the ability to extend the model to support new concepts associated with domain-specific applications, whether it be automotive or aerospace or biomedical. Each has their own unique concepts that they want to express in a standard way. And finally, we want to preserve a migration path for SysML v1 users and implementers to help ensure that we don't lose the investment in the SysML v1 models that have been developed. So these are the core SysML v2 objectives that the language was designed to meet. The key elements of SysML v2 are, first, a new metamodel was developed. SysML v1 was based on the UML metamodel, but we found there were significant limitations in that metamodel in terms of supporting core concepts of systems engineering. So the new metamodel is not constrained by UML. However, it preserves many of the UML modeling capabilities that were incredibly useful. But the focus, again, is on systems modeling. The metamodel is grounded in formal semantics, basically a first-order logic type of semantic that adds precision to the language. The second key element is the ability for SysML v2 to enable very robust visualizations. There's a flexible view and viewpoint specification. Currently, those visualizations are more or less similar to what we had in SysML v1, but the ability for tool vendors to extend this capability to make much more engaging visualizations is there. So we're looking to the tool vendors to take advantage of this mechanism and provide those much more engaging visualizations. Now, in SysML v1, we had graphical and tabular views. In SysML v2, we have the graphical and tabular views, but we've also introduced a textual notation, which again we found to be very useful to complement the graphical representation. The third key element is a standardized application programming interface, an API. And this provides a way for other applications and tools to interface with the system model in a system modeling tool in a standard way. And this, we feel, will substantially promote interoperability. The SysML v2 language capabilities are highlighted here. So in the lower left, you see structure. And when we talk about structure, we refer to the system and the decomposition of that system into its parts, the interconnection of those parts, and the classification of those parts and the systems, as well as the external systems. So that all together constitutes structure. The behavior, similar to SysML v1, includes function-based behavior, similar to SysML v1 activity diagrams, state-based behavior, sequence-based behavior, and use cases. A key distinction is that the behavior in SysML v2, these different behavioral aspects, have been well integrated with each other such that function and state-based sequence and use cases are all nicely integrated, and they're also integrated with structure. On the requirements side, we've extended requirements so they have a formal constraint expression that can be used to more formally specify a requirement. And I'll say a few more words about that. On the analysis side, whereas in SysML v1 we had parametrics, in SysML v2 we have what are called analysis cases. And analysis cases provide a very clean mechanism for specifying an analysis that other analysis tools can then go execute and solve. In addition, SysML v2, along with the textual language, includes a formal expression language for expressing quantitative and logical expressions. We have verification cases, which are quite a bit more robust than the SysML v1 test cases. And finally, we have the view and viewpoint mechanism, the very flexible mechanism that I mentioned a moment ago.